Hi everyone, and welcome to my talk. Today I'll be talking about how to simplify your cloud-native application packaging and deployments. My name is Crone, and I work at Docker on developer tooling. We're responsible for things like Docker Compose, Docker Engine, and the new cloud integrations for AWS ECS and for Azure ACI. Let's take a look at the agenda for today's talk. We'll start with what a cloud-native application is. We'll take a look at some of the packaging and deployment challenges for them. I'll introduce you to Cloud Native Application Bundles, or CNAB. I'll do a quick demo. I'll then talk about how CNAB solves some of the application packaging and deployment problems. I'll show you where to learn more about CNAB. And finally, I'll take questions from the audience. So let's start with this. What is a cloud native application? The first place I looked was in the OED, where they define an application as a program or piece of software designed to fulfill a particular purpose. That's a pretty broad definition, but it gives us a good starting point to discuss cloud-native applications. In general, an application is trying to solve a problem either that the user has or your company has, or something back office that some problem you have. The first aspect of any application is the compute. This is where the logic is running, so the binaries are doing their work, and they're doing calculations. If you're at KubeCon, you'll probably know about containers, which are used on both Docker and Kubernetes. You may also know about things like functions. These are event-based compute, so AWS Lambda or Azure Functions. There's also things like virtual machines or even bare metal, where you can run your application. The next aspect to any application is storage. Every application will probably have some form of state that it needs to store, or it may have assets that it needs to serve to people. So that could be stored in databases, it could be stored in object storage like S3, or in POSIX volumes, so things like EFS. Finally, because we're talking about the cloud, there's definitely networking involved. We need to connect all these components up, and we need to have a way of exposing our application to the end user. That brings us to this landscape, the CNCF landscape. It's very big, but the reason it's big and complicated like this is that no two applications have the same exact needs. So different applications will have different requirements, which will mean they'll probably want to use different tools and different components to build the applications. It is very overwhelming though, and it has several implications on deployment and packaging. Let's take a look at deploying these applications. So I'm not sure if this has happened to everybody in the audience, but it's definitely happened to me. You arrive on a new project and you want to know how to build and deploy the application. The first step is hopefully there's a README that you can read and learn a little bit about the application. There may even be a script or a helper that helps you get started with deploying the application. But inevitably when you run that command, something isn't working because you don't have a tool on your computer, or the README is not up to date, or the script is not up to date. So you'll probably try to debug a bit, download the missing Terraform command that you have over here. You'll probably try to rerun the script, and then you'll run into another one of the common problems, which is that the version that you downloaded is not the same as the version that's used on the project, and so there's some option that doesn't work. You'll try to fix that problem, and you'll probably run into the next problem, which is that yet another binary you don't have on your machine to deploy the application. So let's talk a little bit about deployment tooling of these applications. Well, the first challenge is that often you don't need just one tool to deploy an application, you need multiple. There's always the challenge then of keeping the README up to date to make sure that you have exactly what's required to deploy and manage the application written down somewhere, and that's a manual process. Then, of course, there's versioning of tools. Tools evolve over time, and you need to have the same version as everybody else on your team or as your CI. And then one of my favorites, as a Linux person, it's always another world to get my application running on Windows, because the environment is just so different. These are difficult coordination problems to solve between you and your team, as well as your computer and the CI and your users, especially if you're building end user applications. And this leads to one of my favorite sayings, works on my machine, which is a way for developers to basically say, I got it working, I'm not that interested in making it work for you. So what would ideal development tooling look like? Well, I think it would be defined as code. So the tools, versions, and options should all be written in a file somewhere. And they should be used as part of the deployment process. This is where we can learn from the infrastructure as code movement, which has made infrastructure much more reproducible and much better to use. The other thing that I'd like to see is the same deployment environment everywhere. I don't want to have to think about if this is on Windows, Mac, or Linux and what the person has installed. I just want the same commands to work everywhere. Let's take a look at packaging now. So the first thing that I've noticed when I've looked at cloud native applications is that often you'll be storing different parts of the application in different places. So let's start with the application manifest, or the thing that defines how the components fit together. In this case, I'm going to use compose as the example, but it could be Kubernetes YAML or something else. Often this is stored in a Git repo because it's just a text file. So in this case, I put GitHub, and you can see I have two services inside there, a front and a back, that reference two images. The next piece is the deployment tooling. Well, that's a challenge because, as I showed before, it depends on which computer it's running on. So there's some development tooling on my machine, which hopefully matches that on the CI, and which hopefully then matches what users, if you have any end users, need to run. And then there's application dependencies. So in the case of my application here, it's container-based, and so the container images would go to something like the Docker Hub. You'll notice here that I have at least 3 different places where I'm storing pieces of my application. And this is a problem because, for example, if that image gets deleted, the user front 1.19 image gets deleted, my application won't deploy anymore. But there's no way that somebody who's using the manifest from GitHub will know that. So what would my ideal application packaging look like? Well, I'd love to have an immutable application artifact. I'd love to build my application, test it, and know that when I deploy it into production, it'll be exactly the version of everything that I tested before. I'd also like to be able to store the whole application in one place, preferably a registry. That will allow me to share it easily and have a place where I've archived all the versions of my application. A bonus would be that I'd be able to store my application offline so that I could use it in air-gapped environments or on IoT or other bandwidth-limited places. So that brings me to Cloud Native Application Bundles. What is Cloud Native Application Bundles? Well, we call it CNAB affectionately. A Cloud Native Application Bundle, or a CNAB, are a packaging format specification that describes a technology for bundling, installing, and managing distributed applications that are by design cloud agnostic. So the first thing you should take away from this is that it is a specification and it is cloud agnostic. It's not interested in where you'll be running your application or which tools will be used. It really is designed to be something that solves a problem for everything. So who is the target? Well, the target is clearly people who are building tools like me. The specification is broken up into multiple pieces. The first part is the packaging specification, or what we call the bundle. The next part is the bundle runtime, and we refer to these the actions that you do with the bundle runtime. We have an install, upgrade, and uninstall. So this is basically the life cycle of your application. We then optionally have a bunch of other pieces of the specification. So one piece is lifecycle tracking, which we call claims. We then have registry storage and security, as well as dependencies. Let's take a look at the bundle structure, so how the applications are packaged. We call this the bundle definition, which is usually a bundle.json file. The first part of this is the invocation image. This is often a container image because that's what we're most comfortable with, but it doesn't have to be. The invocation image contains both the application definition, so in the example I gave before, the compose.yaml, as well as the deployment tooling. So in this case, it could be the Docker CLI, it could be the Helm CLI, it could be kubectl or whatever else you need. We also then have some metadata about the application, so things like a name, the author, version, and so on. We have a list of credentials required to deploy the application. So this is a way that the bundle can communicate what permissions and things like that it needs for the deployment and management of the application. We have parameters. So these are minor changes a user may wish to make to the application at runtime. So it could be changing which port the application is serving on or things like that. And then we have a reference to the components that the application depends on. The next part of the specification describes the CNAB runtime. The CNAB runtime includes 3 standard actions. These are install, upgrade, and uninstall. You can also have custom actions, though, for your application. So these could be things that are well known, like status or logs, and they can be stateless or stateful. So, for example, fetching the status of the logs from an application would be stateless. You're not changing the state of the application, but you could have stateful actions where you change the state of the application. The application life cycle is tracked by claims. So basically this keeps track of which operations have been run on your application installation, and when they were done, if they were successful or not, and so forth. It keeps a record of which parameters and outputs were generated and used for each step, or for each time you've made a change to the application. But we only define the data structure for this. We don't define how you do this exactly. There are multiple implementations of this already though. Let's take a look at a demo now where I show you a tool that actually implements the specification. Okay, now that I've introduced CNAB as a specification, let's take a look at a tool that actually implements the specification that you can use. So the tool that I'll be presenting today is called Porter and was developed by Microsoft. If you'd like to get it, you can go to porter.sh. So here you can see I'm running the latest version. The way that you define your bundle with Porter is using a porter.yaml file. So you'll see over here I've created one. There are loads of comments here because I've put all my demo material on GitHub, and I'll give you the link at the end of this talk so that you can run the demos yourself as well. The demo that I'm going to run is going to be to install a WordPress blog into an existing Kubernetes cluster, and I've made the installation process a little bit more complicated to show how CNAB is useful to do complicated installation processes. So what I've decided to do is I've decided to use Terraform to create a namespace, and then Helm to install the application into that namespace. So the first section we see here is the application metadata. We have a name, a bundle name, we have a version, we have a description, and a tag. The tag is used if you're going to be sharing this application through a registry. I'll show some of that later on. We then have this mixin section. Mixins are a way of communicating to Porter which tools you need for your application to be installed and managed. So here I've specified Terraform and Helm, and I've specified a version of Terraform because I need to use a feature in the 0.13 version. We'll only be manipulating Kubernetes objects, so the only set of credentials we need is a kubeconfig. You'll see I've given it a name here of kubeconfig, and the path that I've provided is the place that the config will be mounted into our invocation image, and then the installer. I specified two sets of parameters. We have a context, which is a Kubernetes context, which is defaulting to my Docker desktop context. And we have a namespace, which in this case is kubecon by default. A nifty feature of CNAB is this outputs feature. Often when you're installing things, there'll be auto-generated pieces or bits of information that you need to pass between steps. CNAB provides this out the box with the outputs, so you can take information from one step and output it to another. We now get to the actions, so we have the install action first. As you'd expect, we have two steps. We have a Terraform and we have a Helm step. The first step is where we're going to be creating our namespace, so I'm passing the Kubernetes context we want to use and the namespace that we want to create. And then over here you'll see I have an output of the namespace. That's going to write the namespace that we create as an output so we can use it in future steps. The second step is the Helm chart install, so it's just a simple Helm section with the chart that we want to install and that namespace that we specified earlier. Upgrading this would be a lot simpler. We don't need to do any namespace changes, so I've just got a Helm step here, and that's just going to take the same stable WordPress chart and do the update using that. Finally, we have an install action. Here we have two steps, with the first step being Helm, so the inverse of what we had in the install. That will remove the Helm chart, and then we have Terraform, which will then delete that namespace that it was responsible for. Speaking of Terraform, let's just take a quick look at what I have inside this Terraform folder. So I have a main.tf, which is where the logic is. We only have one resource being managed by Terraform, which is my Kubernetes namespace, and that is set with a variable namespace. As we're using Kubernetes, we need the Kubernetes provider, and here I'm also using a variable to set which context we'll be using. Great, we're now ready to go. So let's open up a terminal and see what the current state of my machine is. So even though I'm using Terraform and Helm, I actually don't have either of these tools installed on my computer. If I check which Terraform, get nothing, and if I do a which Helm, we'll see that I also don't have anything. I do have Docker Desktop running on my computer, and that has its own Kubernetes cluster activated, so I have a Kubernetes cluster running. So we do a kubectl get namespaces, we can see that we have just the default namespaces up and running. All right. I mentioned earlier that we need some way of passing credentials into Porter. Porter doesn't store the credentials itself, but it needs to have a reference so that it knows what will be used. So I have this, I've already set up my Kubernetes config inside Porter credentials. Let's just take a look at what we have inside their credentials list. So I have what I've named kubecred, and if we do a Porter credentials show on this, we'll see that I have linked this to the kubeconfig inside my home directory. So with that, we have everything we need. We've got Docker Desktop running the Kubernetes cluster, I've got Porter installed, and I've linked Porter to my Kubernetes config. So now I can run the Porter install command. I need to specify an application instance, so I'm going to use my app for this case. I need to pass it the credentials that it's going to use, so we're going to pass it kubecred. And then I'm going to change the namespace that we're going to be creating and installing this application into. So it was kubecon. I'm going to change it to hello kubecon. So we just need namespace equals hello kubecon. All right. What this is going to do is it's going to run the installation process inside a container or from a container. So that means that that container has all the tools and things that it needs to do this application installation, and I don't need to have them locally on my computer. So the first step we'll see is that it's going to be creating the namespace with Terraform. The next step we'll see will be the Helm step. So here we go, the namespace has already been created, and here we see Helm installing from that stable WordPress chart. Great. That says it was a success. Porter will tell us then inside, if you do the porter list command, that my app has been installed, the last action was successful, and that was just completed 5 seconds ago. Great. We can start checking on the state of our Kubernetes cluster. So if we do a get namespaces, we're expecting to see a hello kubecon namespace here. Yep, there we go. There's a new hello kubecon namespace. And if we do a get all on that namespace, we can see that some of the components have started coming up. Just like a cooking show, I'm going to go away now, and when I come back, everything will be up and running. All right, I'm back, and our WordPress is now running. So here we can see we have a MariaDB running and a WordPress front end running. So let's take a look if that's actually all up and running on my local host. Before this demo, I opened up my browser and I navigated to localhost, and obviously nothing was running there yet. If I just refresh this page, we should see the default WordPress installation. So here we go. We have a hello world post. And if I click on the sample page, you'll see that I just have the default sample page here. So everything's running on my local host on Kubernetes. Great. So Porter doesn't just handle the installation. It can also do upgrade and uninstall. Let's uninstall this application now, as we don't need it anymore. So to do that, all we need to do is we need to specify uninstall the application instance name, and we need to pass those credentials again because Porter needs access to the Kubernetes cluster. Now we're going to see those steps in reverse. So first we'll see Helm doing a delete, and then we'll see Terraform doing the deletion of the namespace. Terraform will probably take a moment to delete the namespace because it's going to wait until the namespace is empty before it completes the task. So it probably takes about 10 seconds or so. All right, great. So we just installed an application with none of the tools on my local machine, and then we uninstalled it with none of the tools on my machine. Let's look at the next interesting feature that we have with CNAB and Porter. Well, as I said earlier, you can push applications to a registry. Let's get one from the registry and run it locally without having any other source. So I'm going to navigate into my pull directory where we don't have anything. So you can see that I'm not using another porter.yaml or anything like that. On the Docker Hub, you'll see that Deus Labs have put up a Porter Hello bundle. And basically, this is just a Hello World application. All it does is output Hello World text effectively. What we can do then is we can run the Porter install command. We can give it an app instance. So once again, I'll give it the name of my app. I'm going to give it the tag, and I'm going to paste that registry reference. Latest. There you go. What this is going to do in the background is it's going to fetch the bundle and run it and run the installation process locally. Oh, this is how you know it's a real demo, because I made a typo. There we go. That's already run, so it's already downloaded and run. We can see here it ran the installation action first, and that just outputs hello world over here. If we do a porter list, we can see that we have the my app instance installed. And if we do a porter upgrade of my app, it doesn't take any parameters or anything. We can see that we have now upgraded to world 2.0. And if we do a porter list again, we should see that the last successful action was an upgrade. Let's uninstall this now, as we're done with it using porter again. So we'll just do uninstall of my app, and that'll remove it. I didn't need any of the source code or tools or anything on my machine. It just fetched everything from the registry and ran it just like that. Another interesting feature of Porter and of CNAB is that you can output a bundle to disk so that you can use it offline or in air-gapped scenarios. So Porter has the useful archive command to do this. And what that does is creates a tarball containing everything you need for the application. So I'm going to run a Porter archive and save it to my bundle.tgz inside that directory. This will take a moment, so I'll be back. All right, it looks like the archive is done. Let's navigate into that archive directory to see what this looks like. So as expected, we have a bundle.tgz. And if we extract this, we'll see all the files that make up this CNAB. For those familiar with OCI, you'll probably recognize this is an OCI image layout. If we just take a look at the most interesting file here from the CNAB perspective, it's the bundle.json. This is effectively where the bundle definition is stored. And this is the interface that all applications that are CNAB compliant will use. So even though this was created with Porter, another CNAB tool could read this bundle.json and would know what to do. That's the end of the demo. Okay, now that we've seen CNAB in action, let's talk about how it solved some of the deployment problems. So if you remember the example that I gave before, where I tried to deploy an application with a shell script and didn't have any other tools locally, CNAB seems to have solved that. We defined everything we needed inside the porter.yaml file, so as code, and then we only had one command to run on my computer to install the application, even though I didn't have any of the dependencies on my computer. Let's talk about that in light of what I outlined as the ideal deployment tooling. So we defined it as code inside the porter.yaml. We defined the versions we wanted, we defined which tools we needed, and we defined which options we wanted to use. We stored all of this inside the invocation image of the CNAB so that I didn't need to have any of this on my local machine. And then in terms of having the same deployment environment everywhere, because Porter uses containers, it means that we have the same environment if we're using Mac, Windows, or Linux. So we don't need to think about what the developer or the end user is using. That is a much better user experience, both for people on your team, the CI, and for users. Let's talk about some of the packaging for CNAB. So I didn't show you inside the demo how to push a CNAB to a registry, but I can talk to you about how this actually works. Each CNAB is represented by an OCI index. So this is one of the standard container objects that already exists. We've just reused what exists there. From that index, we reference a bunch of objects. The first object is the bundle definition, so that's that bundle.json file. We reference the invocation image. In the CNAB case, or in the Porter case, this is just a container image. And then we also have the components from 1 to n. So depending on which components make up your application, we can also store those in the registry. Because of how those things are stored, they're OCI images, and each one of those will reference a list of blobs, which is just binary data that's stored as part of that. One thing to remember, though, is that storing the components is optional with CNAB. You can either have what we call thin bundles, where you only have the bundle definition and the invocation image, or you can have the thick bundle, which includes the components as well. So conversely to what we saw before, with different pieces in different places, CNAB have now enabled us to store everything in one place. So before we had the application manifest on GitHub, we had the tooling on different people's computers and on the CI nodes and on our end users' computers, and we had the application components on the Docker Hub. Now, with using existing OCI standards, we can store everything inside an OCI compliant registry like the Docker Hub, or we can store it offline inside a tarball. Going back to what we talked about as being ideal application packaging, let's take a look how CNAB fits this. In terms of an immutable application artifact, well, because we're reusing the container infrastructure that already exists, we're using hashes for the components, so we know that what we stored is exactly what we will be using later on. We're also not trying to reinvent the wheel here. We're already using things that have been well tested and exist widely, which is great. We managed to store the whole application inside a registry, and not just the Docker Hub, but you can actually store these CNABs in any OCI-compliant container registry. We also had the ability to store the application offline, which would make it useful for things like air-gapped environments or IoT. And we did this using the OCI image layout, which is something also defined from containers, so we didn't invent anything here. I didn't show in the demo, but CNAB is also very serious about security. We decided to leverage the same mechanisms that exist for containers. So we have things like TUF, or the update framework, and in Toto. All of this has been implemented using Notary, which is an existing technology which is used for containers. We do have some reference tooling for this, which you can take a look at, called Signy, and you can find it on the GitHub, the CNAB GitHub at cnab.io/Signy. If you'd like to learn more about CNAB, I'd suggest you go to these resources. The first one is the CNAB website at cnab.io. My demo code is up on my personal GitHub. Please feel free to clone it and give it a try and let me know if you run into any issues. If you'd like to try out Porter, you just need to go to porter.sh. There's all the instructions you need there to get going. If you're interested in storing things in registries, there's a couple of talks that my colleagues and ex-colleagues will be giving that I recommend. The first one is Sharing is Caring by two of my colleagues, Sylvain and George, who both work at Docker. The second one is Where to Put All That YAML, and that's by one of my old colleagues, Ryan Abrams. Does anybody have any questions?